Hi, I'm Greg Garfin. I'm the University Director of the Southwest Climate Science Center. On behalf of the leadership and the staff of the Southwest Climate Science Center, I'd like to welcome you to this colloquium. I'd like to thank our colleagues with the Climate Assessment for the Southwest for agreeing to collaborate on the colloquium and for sharing their insights, experience, and software for conducting the web broadcast of the colloquium. Before I turn the moderation of the colloquium on connections between climate and fire in the Southwest and its effects on the environment and people in our region over to Ben McMahon, I'd like to acknowledge the effort put into the colloquium by the Southwest Climate Science Center communications team. In particular, I'd like to acknowledge Sudan Kariuki, Amanda Webb, Dominika Husingfeld, Anita Gover, and Colleen Loomis. Collectively, they conceived the colloquium, conducted extensive background research, and made the connections with our speakers, and I'm exceedingly grateful for their efforts.
Thanks, Greg. Yeah. So I'll just do a quick little bit here because we actually want to get to the people who have something to say about fire. Thanks to Greg and all the CSC folks for helping collaborate on this. The big idea here is that we wanted to have an opportunity for some of the fire experts in the region to talk about fire, and thankfully the CSC is rife with experts to talk about that. So today is an opportunity to hear from 4 of the experts in the region about fire in the Southwest. Just a quick piece on this, we'll have 4 panel speakers that will speak for approximately 12 minutes each. And then there will be a panel discussion at the end for Q&A if anybody has any questions. This is also an experiment. Greg mentioned we're sending this out in terms of a webinar, but the webinar videos will also be made available online after the fact. So if anybody has any follow-ups they'd like to see, they can check out the videos again, or if they'd like to circulate them to people who weren't able to be here. So with that, I'd like to first introduce Dr. Dan Cayan with the Scripps Institute of Oceanography. He's going to talk about climate change and expansion of the fire weather season in California. Take it away, Dan.
What I'd like to present real briefly is some projections of climate change that relate to wildfire. A lot of my focus these days has been California, but I've tried to broaden this, at least in part, to the Southwest. And I just want to acknowledge Leroy Westerling, who published a paper back in 2003 that called out the fact that wildfire activity in forested areas across the West was showing a marked increase, sort of a fourfold increase in the number of large wildfires since the 1980 period at the time, and I think we're seeing kind of a continuation of some of that recently. Briefly, what I want to accent is the fact that we are in a region with already high climate variation, natural variation, which of course can produce wetter or drier conditions. Wetter conditions leading to the buildup of fuels, and drier conditions often exacerbating the drying of fuels and really aggravating the wildfire situation. In the future, of course, we almost certainly will see continued and significant warming, and along with that, climate models are suggesting that precipitation regimes in the Southwest will to some extent become more variable, which could, at times anyway, make this problem more acute. And together with the warming would create drier landscapes. With warming, of course, the humidities will decline, at least during the daytimes. So this is a picture of precipitation historically over the South Coast region where I live in the San Diego area. And the point of this is simply to indicate that we have lots of variability. In fact, Southern California happens to be really the apex of precipitation variability in a relative sense across the nation. But this is kind of emblematic across the Southwest. That lower map shows coefficients of variation of annual precipitation across the United States, that a map that was put together by Mike Dettinger, a colleague of ours, indicating that the blue to yellow colors are relatively high variability, and you can see how those cluster in the Southwest. Recently, of course, we've seen quite a lot of dryness across the California and Southwest region. In our area since 2007, we've had really 3 wet years and several dry years. So we've had quite a spell of dryness. Along with that, there's been quite a lot of unusually warm seasonal temperatures in this relatively recent period. Actually, warmth going back to the late 90s, but certainly since 2011, we've seen remarkable warmth, both in the cool season. The left-hand map is a November through March time slice of the climate divisional data. The shading is intuitive, but you can read the legend there as far as the scale. And also, interestingly, in the summer season, May through September as well, which is shown on the right-hand panel. In fact, the whole West pretty much has been quite warm. In California, these last few years have really risen above the envelope of variability of temperature, which is plotted here on the vertical axis on this scatter plot, which shows temperatures and precipitations plotted on the horizontal axis over the period from 1915 through 2015. What you can note here, these actually are 3-year averages centered on the middle year, but the years between 2012 and 2015 are those left-hand meaning relatively dry, and upper meaning quite warm dots. The dots actually represent snow water equivalent aggregated over the California mountainous region. And the way this works is that it's an inverse scale. So the larger the dot, the greater the deficit. And you can see the unusually reduced snow water equivalent in, actually that's the period between 2013 and 2015, which is that largest, warmest dot there. So the temperatures have had a extraordinary impact on hydrologic characteristics across the landscape. As we look forward, the Southwest is facing increasing temperatures of at least a few to several degrees, depending on emissions of greenhouse gases. And what we're showing here is an ensemble of 30 plus models run internationally and downscaled over, in this case, this is California, but it really represents the Southwest. The dark blue is the median temperature over these several models carried out through the 21st century, showing about a 5 degrees Fahrenheit increase from the historical period of the late 20th century. And the red is a higher greenhouse gas scenario, RCP 8.5, as compared to the RCP 4.5 scenario in blue, which shows, particularly in the latter half of the 21st century, quite unusually strong warming over an annual period there. So almost double what the moderate scenario is. The right-hand slice simply shows that over aggregate time slices. Along with that, interestingly, what we've noticed is that precipitation in parts of the Southwest become more volatile, more dry days, occasionally very wet days because of the buildup of humidity in the atmosphere and the requisite storm dynamics. But more dry days really is a prescription for more dry years. And here we're showing for the RCP 8.5 simulations, again, in aggregate over, in this case, 32 of them, the occurrence in sort of a sliding 30-year window of dry years at various thresholds of dryness from the first percentile to the 20th percentile. So that number of dry years is increasing on aggregate over these models over time. An interesting part of the precipitation changes that models present in the future is the fact that although changes in annual precipitation are not really that impressive over much of the Southwest, the lower part of the Southwest may decline in terms of annual precipitation somewhat by the end of the century. But the models are pretty decided in that there are some seasonal changes wherein the shoulder seasons, particularly spring, exhibits a decline in precipitation. So in this particular slide, I'm showing the lower Colorado basin, which is sketched out in the little postage stamp map there at the right, and showing the results of, again, 30 plus of these GCMs month by month in terms of percent change of precipitation there at the bottom. The temperature changes month by month are shown there at the top, in this case in degrees Celsius. But we're seeing in the springtime there changes of 30% or more reduction in precipitation in the median of these several climate models for the higher emission scenario. If you want to see that in terms of the play out over the landscape, that's shown here in this set of maps in January for left across to April, May, and June. And you can see particularly March, April, May spell a real drier picture for the Southwest. Relative humidity in the atmosphere, of course, as the air gets warmer, the minimum relative humidity, so that would be daytime, changes fairly markedly by way of getting lower over spring and summer, in particular over much of the west and the southwest, which is shown there in maps. DJF, of course, December through February. MAM is March, April, May, and JJA June, July, August. So all in all, we're seeing a more volatile, warmer, and occasionally, in terms of precipitation delivery, drier future with the warming aggravating the dryness of the landscape. So that's where I'm going to stop and leave it to my colleagues to pick up more on the details of the actual wildfire phenomena in the West.
All right, thanks, Sam. Let's give a round of applause. Quick consultation with the executive.